Good day YouTube, welcome to math.serve.com, and this clip we're going to be going over an easy way on how to factor quadratics. Alright, so the instruction for the example we're about to do is to factor the given expression. So let's say we have the quadratic expression 7b squared minus 9b minus 10. Alright, so let's go ahead and factor it. Now, every time you're factoring polynomial expressions, the first thing you want to do is always check to see if there is a greatest common factor that can be factored out from every single term. Okay? So if we take a look at this expression right here, if you consider 7, 9, and 10, is there any common factor? Is there a number that goes into 7, 9, and 10? And the answer is no, because first of all, 7 is prime, and 7 doesn't go into 9 or 10, so there isn't the greatest common factor that can be pulled out from the numbers. When it comes to the variables, there's a b squared here and there's a b. b is common to these first two terms, but the last term, the constant term, does not have any variables, so b is not the greatest common factor. Okay, so the greatest common factor of these three terms is 1, which is excellent, which means that there is no work that should be done initially before factoring. Okay, so let's go ahead and get started with the factorization process. First thing we want to do is we want to determine what a, b, and c are. Since it's written in standard form in descending order of degrees, a is going to be 7, b is going to be 9, and c is going to be 10, negative 10. Okay? Alright, so a is 7, b is negative 9, c is negative 10. Let's go ahead and write it down here. A is 7, b is negative 9, and c is negative 10. Okay, now we have three terms here. The goal is to express this quadratic trinomial as a quadratic with 4 terms, so we can factor by grouping. Alright, so the question is, how can I split this middle term up into 2 terms so that this quadratic trinomial can be written as a polynomial with a quadratic with 4 terms where we can factor by grouping? That's the goal. Okay, so what are those 2 special numbers? To figure that out, what we're going to do is we're going to play a game. The game is called the X game. Okay, so let's create our X. How do we play the X game? Well, you put a times c on the top, and you put b on the bottom. Alright, so what is a times c? We know a is 7 and c is negative 10. So a times c is simply going to be 7 times negative 10, which is negative 70. So that goes on the top, and b is negative 9, and that goes on the bottom. Alright, we are ready to play. So the question now is, what 2 numbers add to give you negative 9 and multiply to give you negative 70? So to help us figure out what those 2 special numbers are, we're going to go ahead and create our factor t-chart. The target number is 70. So what we're going to do is write down all the pair of integers that multiply to give you 70. Forget about the signs for now, we'll deal with that later. Okay? So we know 1 goes into every number, so 1 goes into 70 times, or 1 times 70 is 70. How about 2? Does 2 go into 70? Absolutely. How do we know? 70 is even. 2 goes into every even number. Okay, so 2 times 35 is 70. How about 3? If you add the digits of 70, do you get a multiple of 3? So 7 plus 0 is 7. Does 3 go into 7? The answer is no, right? We know 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 7 is not a multiple of 3, so we don't put 3 here. How about 4? Look at this number. The last two digits, this is a two-digit number. Does 4 go into 70? The answer is no. 4 goes into 7 once. If you carry over 3, 4 does not go into 30. Okay, let's go on with our list. How about 5? Absolutely. How do we know 5 goes into 70? Every number that ends with 0 or 5 is a multiple of 5. Okay? So 5 goes into 70. You can do the long division. 5 goes into 7 once. Carry over 2. 5 goes into 20 4 times. How about 6? Since 3 does not go into 70, 6 does not go into 70, since 6 is a multiple of 3. Okay? How about 7? Absolutely. 7 goes into 70 10 times. And then 8, 4 doesn't go into 70, so 8 cannot go into 70. 9, 3 doesn't go in there, so 9 automatically does not go in. Alright, so we have a complete chart right here. We have all the pair of integers that multiply to give us 70. Now the question is, which pair add or subtract to give us our target number of 9? So forget about the sign for now, we just focus on the number, okay? So if you take a look at 1 and 70, this pair, if you subtract them, you get 69. If you add them, you get 71. 2 and 35, if you subtract, you get 33. If you add, you get 37. 5 and 14, if you subtract, you get 9. If you add, you get 19. 7 and 10, if you subtract, you get 3. If you add, you get 17. So which of these pairs yields 9 plus or minus 9? 5 and 14, you see this 9 right here? This is our target pair. Okay, so we're going to put these numbers here into our X game, 5 and 14, and see if we can make the signs work. Okay, so let's see. The sum is negative and the product is negative. The sum is negative. If we take a look at these two numbers, the bigger of the two has to be negative, since the sum is a negative number. The absolute value of the sum is in between these two. Okay, so put a minus here. 5 minus 14 is negative 9, and 5 times negative 14 is 70. Excellent, that's what we want. So what we're going to do is we're going to bring down the leading term and the constant term, and we're going to replace the middle term with these two numbers. Okay, so we're going to put down negative 5, bring down the b, actually it's positive 5, minus 14, bring down the b, and then drop down the constant term, negative 10. Remember, the original goal was to write this quadratic trinomial as a quadratic with 4 terms that can be factored by grouping. So let's show you how that works in action right now. So what we're going to do is we're going to partition our quadratic with 4 terms down the center. We have two worlds, okay? We have the first pair and the second pair. We're now going to factor by grouping. So let's decompose every term to make the factorization process easy. So we're going to have 7 times b, that's 7b squared, plus 5 times b. And then 14, what's the decomposition of 14? Let's do that here. 14, 2 goes into 14 7 times. So 14 is 2 times 7, and then times the b, and then 10 can be decomposed into what? 2 goes into 10 5 times, so 10 can be written as 2 times 5. Okay, so we've decomposed all our terms. We're now going to factor. Taking a look at the first pair, do we have any common factors? The answer is yes. B is common to the two terms on the left side. So if we factor out b, is as though we are dividing by b. We're going to be left with 7 times b, which is 7b plus 5. Now to the right side, we have a minus and a minus. So we're going to factor out a minus, which will change this to a plus. And is there anything that's common other than the minuses? 2 and 2 are common. So we factor out a 2. And we're left with 7b. Because we took out the minus, this minus becomes a plus, plus 5. Bam. Now this is where you freeze and check. If your factoring by grouping is correct, guess what? These two terms in the parentheses must be identical. Is that the case here? Yes, it is. They're identical, which shows that our factorization process is correct so far. Okay? So now what are we going to do next? These two identical terms can be factored out. So that gives us 7b plus 5. And it's nice little parentheses. And then the terms on the outside will be left to be grouped together in their own parentheses. b minus 2. Okay? So this, ladies and gentlemen, is the factored form of the original quadratic trinomial, factored form. So every quadratic trinomial that's factorable, this XGame method is an excellent way to factor the expression correctly. Alright, so how well did you master the procedure we just covered in the previous example? To demonstrate mastery, we would like you to try out the following problems, okay? So try these. Instructions are to factor the given expressions completely. Alright, so what you're going to do is you're going to copy down these problems, pause the video, factor them completely, and then reinitiate the playback and see if your answers are correct, because we'll be displaying the answers momentarily, okay? So question 1 is 2b squared plus 11b plus 9. Question 2 is 3v squared plus 11v minus 4. Question 3 is 7p squared minus p minus 6. Okay? So go ahead and pause the video at this time. Try and factor these three expressions and then continue playing the video to see what the answers are. Alright, welcome back. Hopefully you had a chance to try to factor out these three expressions. Let's go ahead and take a look at the answers. Question 1, the factored form is 2b plus 9 times b plus 1. Question 2, the factored form is 3b minus 1 times b plus 4. Question 3, the factored form is 7p plus 6 times p minus 1. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your study of the factorization of polynomials, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any algebra precalculus calc questions in general, just place your questions in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More tutorials and support tools can be found at mathgotserved.com. Go ahead and check it out. Thanks again for watching and have a wonderful day. Goodbye.